Hey there, math magicians. Welcome back to another lesson in Algebra 1. Today's lesson is titled Notes, Lesson 11.3, because we are in Unit 11 in the third section. And we're going to learn how to simplify rational expressions. Basically, what this means, simplifying rational expressions, what that means is reducing fractions. Reducing algebraic fractions. All right? So that's what you're going to spend tonight doing, or today. You're going to be reducing algebraic fractions. All right, I'll let you get caught up. You might want to pause the video to get all this written down, and then we'll begin. All right, the key to this lesson and the next several lessons is that you have to factor first. All right, so you're going to hear me say that for the next several days. Factor first. That is the key. All right, so let's just remind ourselves what exactly it means to factor. So there are many ways to factor. Whoops, I don't want to do that. So there are many ways to factor. And the first thing you're supposed to look for is a GCF. All right, is there a greatest common factor? Next, maybe it's a binomial, and maybe they are the difference of perfect squares. Difference of perfect squares. Maybe it's an easy trinomial that can be factored. Maybe it's a trinomial that requires the British method. Or maybe it's a quad or more, a polynomial with 4 or more terms that would require grouping. Okay, so we have learned all these forms of factoring. You even did a project on factoring, so hopefully you can remember it all. So again, what do you do first? You factor first. Factor first, and you're going to want to do that throughout almost the rest of this unit. Factor, 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 and do it first. And how do you factor? Well, you always look for a GCF first, a greatest common factor. If it's a binomial, it might be the difference of perfect squares. It might be an easy trinomial. It might be a trinomial that requires the British method. Or it might have 4 or more terms, which would require the grouping method. All right, so the better you are at factoring, the more you remember your factoring skills, the easier the rest of this unit will be. All right, let's try some examples. So here are some examples. Okay, number 1. Let's say you had 21x divided by 7x squared. Okay, you're supposed to look to see if you can factor. Okay, factor first. Basically, this is already factored, because to be factored, it means everything's multiplied. everything's multiplied. So if you look in the numerator, you have 21 times x. And in the denominator, you have 7 times x squared. It's pretty much factored already, but you could rewrite the numerator. And you could write 21 as 7 times 3, and then times the x. And then underneath, you could think of that as 7, and then times x squared, which would be x times x. And as long as everything's multiplied out, as long as it's all multiplication, you are allowed to cancel. So 7 divided by 7 is 1, and x divided by x is 1. Any number divided by itself is 1. And so your final answer, your final solution, or simplified fraction, is 3 divided by x. Now, you also have to be aware of excluded values because we're dealing with fractions, and you can never have 0 in the denominator. You can't have 0 down underneath. So what would make this denominator equal to 0? Well, that would be x can't be 0, right? If x were 0 down here, you'd have 7 times 0 times 0, which would be 0, and that's not allowed. So you have to write your excluded value. X cannot equal 0. All right, so here's your simplified fraction, and here is your excluded value. All right, let's take a look at number 2. Number 2. Let's go with 5 divided by 10 minus c. Okay, we could factor maybe. Let's see, 5 would just be 5 times 1, so there's nothing really worth factoring there. This does not have a GCF. It's a difference, but these are not perfect squares, so it's not the difference of perfect squares. It's obviously not a trinomial because there's only 2 terms. And it's not more than 3 terms. I mean, it's 2 terms, so you wouldn't use grouping. All right, so this can't be factored. And you cannot cancel the 5 and the 10 because this is subtraction. You can only cancel when it's multiplication, like in this one. We had multiplication, multiplication. So this one's actually done. All right, this is simplified. And what's your excluded value? What would make this denominator equal to 0? Well, 10 minus 10 would equal 0. So your excluded value, c cannot equal 10. All right, let's try our third problem. Let's go 2w to the third all over 8w to the third plus 40w squared. Okay, don't just start canceling. You cannot cancel until it's multiplication, and that's why you have to factor. When you factor things, you're putting them in lots of different multiplied terms. Okay. All right. So the numerator. You could write 2w to the third. You could make it 2 times w times w times w. That might help. We'll see. Those are times. Sorry, they're kind of sloppy. Underneath, okay, let's see. Is there a GCF? Why, yes, there is a GCF. Both of these can be divided by 8 and w squared. So the GCF is 8w squared. And remember, you like undistribute. So 8w squared times just plain old w would give me 8w to the third. And then 8w squared times positive 5, right? 8w squared times 5, isn't that 40w squared? Okay, you can rewrite, all right, let's leave the numerator, 2 times w times w times w, and underneath we could write 8w squared as 8 times w, and then times w plus 5. Alright, so we have things being broken down by multiplication, so we can start canceling. W divided by w is 1. That w cancels out. 2/8. 2/8. 2 goes into 2 once, and 2 goes into 8 4 times. Now you cannot cancel these two. You cannot cancel these w's because that w is a plus. That's a w plus 5. It goes together, w plus 5. Alright, so our final answer, on the top we have a 1w, and underneath we have a 4 and a quantity of w plus 5. So we have 1w and then 4 times w plus 5. And you're going to be tempted to cancel that w there because you're like, there's multiplication. Right, okay, but there's plus. Can't cancel. Now you have to look for excluded values. So look in the denominator. And w cannot be, I'll write it over here. Let's see here. W can't be 0 because if you multiplied by 0 here, the whole thing would be 0. And w can't be -5 because what's 5 plus -5? 5 plus -5 would be 0. So w can't be 0 or -5. There's your excluded values. All right, we'll try 2 more. But I think I'll put the last 2 examples on a second video. So you'll have to watch one more video and it'll have 2 examples.